I got one in the back, but he works here, so I don't think he counts. So yeah, Summit's about to wrap up, but please don't forget to go to Ship It Live after this. It'll be in the main stage. It's very fun. You get to see how Atlassian does their hackathons. But before that, we have our last talk of the day. We have Peggy, and I wanted to give everybody a heads up if you guys were using the printed material instead of the app. There was apparently a printing mistake who thought Nicola's talk was at 2:30. So it is not, in fact, Nicola's talk. That actually just happened, but that will be recorded and up by 5 p.m. at summit.atlassian.com. Also, he's in the back, and I can still see him if you want to go bombard him with questions later. But up next, we have Peggy, who has traveled here from Sydney, and I'm really excited about her talk. She's been at Atlassian for a while, and she's been working across different teams from integration to plugins to purchasing, and through all of this in her journey, she's learned the ways of taming the legacy monolith and wants to bestow that knowledge upon you guys. So, Peggy, come join me.
Thank you. Cool. Clicker is on. So yes, today I'm going to tell you some tips and tricks that we learned in our team on how to work with legacy code. And in order to do that, I'm going to tell you a story about the team that I've been working with for the past 12 months or so, and that is Team Aurora. So this here is our team. We're about to have team lunch because food is very important. And our team looked slightly different about 12 months ago. We were a much smaller team, and we weren't working on a legacy monolith, as you might imagine. In fact, we were working on a microservice. It was a completely greenfield project, 0 lines of code. We got to spike the technology we wanted. We decided to do test-driven development, and everything was good. Our build processes were fast. We had quick dev feedback loops, and we were enjoying ourselves. But as with most systems, things don't live in a silo. They don't live in a bubble. They depend on other systems. And as you can imagine, our microservice, our shiny new microservice system, depended on a legacy monolith. So this was a problem for us, and it was a pain point, because quite often we realized that we needed to make changes to the legacy monolith. Sometimes it was bugs, sometimes it was new features. But the problem was we didn't know how to make these changes, because the legacy monolith was a big mess to us. Luckily, though, we did have a team of experts that knew exactly what to do with the legacy monolith. They were called experts for a really good reason. They knew the legacy monolith inside out. They were working on it, trying to improve it, and we depended on them quite a bit. When we needed bugs fixed, we raised an issue for them. When we needed features, we raised an issue as well. And in general, this worked quite well, but over time, we realized that this wasn't working exactly as well as we had liked, because they had their own roadmap, they had their own sprints, and they had their own goals that were very different to ours. And over time, we realized that we were missing our sprint deadlines because some of the bugs that were critical for us were not critical for them. So it wasn't on their next sprint, which meant our sprint got pushed back and we were missing our deadlines. So this didn't work for us, and it didn't work for them either. So what did we do? We decided to reshuffle the teams and try and get this to work. The teams now looked a bit different. They had an expert in each team. So the idea behind this was that if we had an expert on the team, then they would have the same goals and the same roadmaps, and they would be able to work with us and get this feature done. Unfortunately, the legacy monolith is a beast, and it's not that easy to tame. Simply by reshuffling teams didn't quite work as we had hoped. So we read the literature that existed out there, and a lot of the literature says, write tests. Now, I fully agree with this. We definitely should write tests to start working with any code base, in particular legacy code bases. But the problem we had is, in order to write good tests, tests that actually make sense and can actually give you confidence when you're modifying code, you need to first understand the code that you're writing tests for. And we only had one expert in our team that could do this. And he was already inundated with issues, so he didn't have the time nor the capacity to write these tests. Something that some people suggest is rewrite the code base, rewrite the legacy monolith from scratch. Now, I can hear some laughter. This is definitely not a good idea because it's a monolith, it's a legacy code base, it's going to take a lot of time. On top of this, your legacy monolith, even though it may be hard to work with, has existed in your organization, it's been running in production for many years, and it's proven to be working, right? You have people using it day in, day out. You have business logic that has weaved into it over the years, and you know it works. And as bad as it sounds, a rewrite might not necessarily be better. Chances are you're just going to be introducing a whole new bucket of issues to this new legacy monolith. If you haven't yet read Joel Spolsky's Things That You Should Never Do, I highly recommend you read it because in there he highlights the mistakes that Netscape made when they decided to rewrite their browser from scratch and therefore became redundant in the internet. So what does this mean? Rewrite was off the table. We weren't yet able to write tests. What this meant for our team was we very quickly learned what not to do. We learned that even after the reshuffle, which helped us a tiny bit, we learned relying on the expert to finish the issues was not the solution. It seemed to make sense, right? You have dozens of issues coming in each week, some related to the new microservice, some related to the old code. And the expert, being the expert of the monolith, could pick up the code, knew what to do, and could finish the issue and turn it around within a reasonable period of time. So we did this for the first few weeks, but then we realized that the expert started to become a bottleneck. He was the only person that could pick up these issues, and they started to pile up. And as with legacy code bases, sometimes when you think something takes 3 days, it actually ends up taking 2 weeks. So he was becoming a bottleneck, and again, we were missing our deadlines. And on a slightly different note, we realized that we weren't really working as a team. We had one expert working on a code base, pretty much siloed from the rest of the team who was working on the new microservice. Not only was it not fair for him, because working on legacy code is never as fun as working on new code bases where you have high velocity. We weren't working together or communicating well as a team, as a whole unit. And finally, understanding. The rest of the team didn't really have a good understanding of how the legacy code base worked. And this meant that we commonly misunderstood what the legacy code base was doing. In fact, because of this misunderstanding, we accidentally implemented a bug in our new microservice because we thought the legacy did one thing. We implemented it under that assumption and realized, oh crap, it actually did something else. And if those three isn't enough to convince you that relying on your experts to finish the issues is not a good idea, there is always the bus factor. So it might not be as extreme as your expert being run over by a bus when he goes and grabs lunch, but you never know what will happen. Your expert might change teams. He might go on a long vacation, or maybe even change companies. The key point is you don't want to lose the knowledge and be dependent on one particular person for your sprint deadlines and for your projects. You want to make sure that regardless of what composition you have in your team, you can still continue and meet your deadlines. So what now? We knew we needed to do something to change the way we worked because we couldn't keep relying on the expert and we couldn't keep missing our deadlines. So for the rest of the team, people like myself who were learning about the code, the legacy monolith was quite literally a black box to us. We didn't know anything about the code. It was dark. And when we did finally pry open this black box, the code was really hard to work with. We didn't know what was happening. We didn't know why things were done in a particular way. Now I'm going to stop here and do a quick disclaimer. I'm not saying that the code was badly written. In fact, I don't think any developer sets out to write bad code. The fact is, over the years, as you're developing, there's priorities, there's deadlines, and inevitably you accumulate code debt. And the more years there is to a legacy code base, the more code debt you accumulate and the harder it is to work with. On top of this, you also have the fact that best practices in software changes over the years. So 5 years ago, something was considered excellent programming practice, might not be the case now, and you see this evolution and these differences of coding practices in your code. So for us, we didn't really understand the code, and it was really hard to work with. And these two things combined meant we were afraid. We were afraid to modify the code. We didn't want to fix a bug only to introduce another bug. We didn't want to add a feature only to realize that it was in conflict with an existing feature. So we realized that in order to work with a legacy code base, we needed to decipher this black box and truly understand what was happening inside the legacy monolith before we could progress and actually do anything. So what did we do? We did achieve this. The rest of the team now is slowly starting to get a hang of the legacy monolith, and we are working in the code base. So what we did was we relied on the expert. We didn't rely on the expert to complete the issues. Instead, we relied on the expert to share their knowledge, to make sure that they shared the knowledge to the rest of the team so the other team members could understand what was happening. And over the 12 months, we realized there were lots of techniques that helped us a lot. And I'm going to go through some of the common techniques. And the key part here is these are techniques that you probably already use in your organization, but there are some, I guess, tips and tricks to make it even more effective for legacy code bases. So the first technique is brown bags. So brown bags are a great way to share a lot of knowledge in a short period of time to a lot of people. So effectively, brown bags, generally held over lunch, but it could just be a 1-hour meeting, is when the expert is there to share their tribal knowledge, the knowledge that they've gained over the years to the rest of the team. The key point here is you want to make sure your brown bag sessions are not just about everything and anything, but they're about a specific point. They're contextualized into perhaps the work you're doing or questions that have been asked in the recent few weeks as you're working on the code base. So you want to make sure brown bags, maybe it could be about a particular module of the legacy code base. Something small and something easy to understand that people can start building their understanding towards. Now, brown bags don't need to be technical. In fact, I don't think they should be. They should be there to give people an understanding and an overview of how the system works, the decisions that have been made, and how things are flowing. But in order to work on the code base, you definitely need to have a technical understanding. And in order to do this, there are lots of other techniques, and one of them is pair programming. So the great thing about pair programming, and I'm just going to take a quick detour, is pair programming is when you have two developers working on the one issue on the one computer. So you have the driver, who is the person who has control of the keyboard and the mouse, and then you have the passenger, who is a person sitting behind the driver or beside the driver, and they're there actively helping the driver to solve the issues and solve the problem. They're not typing, they're just there as support. So pair programming is great to share knowledge because you have two people working on the one issue, and so you're sharing the knowledge as you're completing the issue. When we first started with pair programming, we had the expert in the driver's seat. It seemed to make sense for us. You have someone who understands the code base, work on the issue, and explain it to the person who's learning about the code as they go along. However, I don't recommend this. What I recommend is have the expert be in the passenger seat and have the person who is learning about the code be in the driver's seat. Now, I guarantee you this will slow down your velocity because the person who has no idea about the code, like myself, is in the driver's seat. I have control of the keyboard, but I don't know what to do. But even though you might receive pushback from this, it is critical to do this and not have the expert be in the driver's seat because by having them sit in the passenger seat, you're forcing the driver, so the person learning the code, to actually understand what they're doing. Even though the expert may be the one telling me exactly what to do, which files to open, what to type in, I have to understand and know what he's saying before I can complete the issue. If I open the wrong file, or I type in the wrong code, or I don't agree with what he's saying, I can ask questions and get a better understanding of why things are done. And on top of this, it is always better to learn by doing than by observing. Another good technique for sharing technical knowledge is code reviews. So as with all code reviews, you should always make sure your code review or your pull request is of reasonable size. You don't want it to be too large and too overwhelming. And this is very critical for legacy code bases because the code base itself is already massive. You want to make sure that the review that you're asking someone to look at is of reasonable size. If you're the creator of the code review, there are two things that you really want to make sure. The first one is you want to make sure that you add the expert to the code review, no matter how small the change is, because you never know, you may subtly be introducing a bug and you want the expert to be on top of it. You want them to be there to say, you shouldn't have done this here because this introduces a bug in this other module. And the second thing is, when you do add your colleagues to the code review, and you definitely should, make sure you add someone who has already worked in that area of code. So the reason for this is, if they've never touched that area of code before, they're not going to know what's happening, they're not going to have enough context to be able to effectively review your code. So you're going to be wasting their time and your time as well. A good twist to code reviews that we used that helped us immensely was over-the-shoulder code reviews. As the name suggests, you're standing over someone's shoulder as you conduct the code review. Now this is excellent for face-to-face feedback and immediate feedback. This is especially good when you're starting to work on the code base and you're very fresh to it, because it means that you have the opportunity to ask all those random silly questions that you're not aware of, but it's a bit too cumbersome to ask over an asynchronous channel. So as a reviewer, you can ask for clarification. You can get a better understanding of why things were done and decisions that were made. And if you're the creator of the code review, there is no better way than to check that you have actually understood what you've done than to explain to someone else why you've done what you've done. So I highly recommend over-the-shoulder code reviews, especially when you're just starting off. So over the months, as we implemented these techniques, we realized that there were other techniques that were also very powerful and useful. In fact, the next technique that I'm going to tell you is something that we think, or that we felt, made the biggest impact to our team. And the best thing is, it is completely trivial to implement. So this technique is the fact that when you drag an issue from the to-do column to the in progress, make sure the assignee is not the expert. So make sure the assignee is someone who is new to the code base. The reason for this is by being the assignee of an issue, you naturally pick up the accountability and the responsibility of the issue. You become the person responsible to see the issue through QA kickoff, through implementation, through code reviews, through QA demos, merged into master, deployed into production, making sure that everything is still working as expected. And if an external team does have a question for you about this issue, they will see that you're assigned to this issue because your avatar's next to it, and they will ask you the question. You may or may not be able to answer that question. You might have to defer back to the expert, but at least you know what other teams are interested about the legacy code base. So simply by being the assignee of the issue, you start to learn a lot more about the peripherals of the legacy code base, which is really important and critical when you want to learn about how to work with the legacy code base. In addition to this, by being the assignee, there's also a lot of other ripple effects. One of them is your dev environment. By being the assignee, it sort of forces you to set up your dev environment. This may sound like a no-brainer. Of course, you should set up your dev environment. You're a dev. But with legacy environments, it can take hours, if not days, to set up your environment so you can actually work on the code base. Now, if you don't have a forcing function to set up your dev environment, you might always defer to work on someone else's computer. But by having it set up on your own computer, it means that you can work on the code base whenever you want. It doesn't matter if someone else is on a meeting or at lunch, you can still tinker around and poke around the code base. And on top of that, because the dev environment is set up on my computer, it means that I can work on it. It means that it's easier for me to be the driver when I'm pair programming, because I have my shortcuts, I have my hot corners set up, and it's always easier to work on my own machine as a driver. And last but not least, the other ripple effect for the expert not being the assignee of any of the issues that we found is that they were more available to help people out. Our expert, Peter, was no longer tied down to an issue. He didn't have to see it from the start to the end. He was able to float around and help us out as we struggled with the issues. Quite often what would happen is he would pair with us. So say pair with me in the first half of the day, and then go and pair with Sasha for the next half of the day. And this way he was spreading his knowledge whilst not being tied down to just one particular issue. He was able to parallelize the issues that were being worked on. And this was incredibly useful because of the knowledge sharing that we gained. So over the months, as we worked on the issues, as we owned issues, we realized that we were starting to get an understanding of this monolith. And we realized that it was time to actually tame the monolith, so we needed to improve the code. Now, the best way to improve code is obviously to delete code. If the code isn't there, it's not there to confuse you. You can't be confused by it. So if you find any code that is dead, delete it. Unfortunately, though, not all code can be deleted. I wish all code can be deleted, but that's not the case. So sometimes you have to refactor the code. Now, I'm not talking about huge refactors where you rip apart the structure and modify hundreds of files at a time. I'm talking about small refactors, something that you just change, probably even the one or the two files that you've been touching. It can be something simple, renaming variables, or maybe even just reducing some duplication, changing something, so changing the order of the method so that it makes a bit more sense when you're reading it. Maybe even updating comments or documentation on your wiki, something that makes it easier for you to work with the code base. And one point with refactoring is you want to make sure that you time boxes, because even with a small refactor, legacy code-based refactorings can go down a rabbit hole. So give yourself a day, maybe 2 days at most, to refactor the code base, because you don't want to spend too much time refactoring something if it's going to take forever. And last but not least, write tests. So now that you do understand the code base a bit, you can write tests. Definitely write tests for the new functionality that you've introduced. Make sure that there will be no regression in the future. Test for all the edge cases. Write tests for the bug that you've that you fixed. And of course, if you can, update or add tests for the existing area of code that you've touched. Because in order to modify that code base, you've already spent the effort and the time to understand it. So that means that you have the opportunity to write the tests that will make it easier for you in the future when you come back to modify this code base. Now, I'm not going to lie to you. The past 12 months was hard. It wasn't easy to work with a legacy monolith. It's much easier to work with a new microservice that has a feedback loop time of maybe 2-3 seconds, as opposed to a legacy monolith where it took me like 2 days to set up the environment, and often it still breaks. And quite often, it felt like we were going in circles. We would learn something new, get a better understanding, but then realize, oh crap, there's a whole new module that I don't even know about, or there's a whole new repository that depends on the legacy monolith that I don't know about. But this is a time when you sort of have to take a step back and realize that you actually have improved. You actually do understand the code base a bit better now. And this is important because with more members of your team understanding the code base, it means that there'll be less bottlenecks. It is okay now that your expert goes on holidays because other members of the team can pick this up and continue with it. With more people who understand the code base, it means you have more eyes and more experience, so you have a higher chance of finding and fixing bugs. And with more people who understand the code base, it obviously means you have more people who can work on the code base, who can delete code, refactor code, write tests, So in general, you have a better code, your code will be better than how you started with. So you have improved code. So I'd like you to imagine now that you're working in the team that I've been working on, Team Aurora, and you have a new critical feature that you need to complete for this microservice. You need it to be deployed by the end of the month. Everything is going great, except you realize that it depends on the legacy monolith and there is a bug. And worse yet, your expert is on holidays. He's gone to Hawaii for 12 months. Now, 12 months ago, this would have been a panic moment. No one else on your team knows how to deal with this issue. It's a bug in the legacy code base. You don't know where to start. And your expert is AWOL. However, in the past 12 months, you've worked hard, so this is no longer the case. In the past 12 months, you've attended brown bag sessions. You've done a lot of pair programming, and you've done a lot of code reviews. You've asked all those random silly questions that have been nagging you when you did the over-the-shoulder code reviews. You've also owned issues end to end, so you know exactly what the deployment process is like. You're not afraid of it. You have your dev environment set up, ready to go. You can dive straight into the issue and start working on it. And even though your expert is on holidays, you also have the rest of the team. They also understand and know what is happening with the code base. So you can also ask them for help. And luck has it, this is an area of code that you have worked on in the past. So the code is a bit cleaner, there's a bit more documentation and comments, and you actually have a good suite of tests that are there to help you out. So you pick up this issue related to the legacy code base, you fix the bug, get it deployed into production, and then you continue working on the critical feature that you successfully deploy by the end of the month. And everyone is happy because you haven't missed your deadline and you've actually tamed the legacy monolith. Thank you.
All right, we've got time for a few questions. So Peggy, the most upvoted one that seems pretty popular is, how do you recommend dealing with legacy code if there is no expert anymore or their availability is limited?
That's an interesting one. So if there is no expert, I would recommend trying to look at the smallest component that you have and trying to, I guess, reverse engineer it. So how is it used? Who are the stakeholders and what do they need from that code base? And then try to reverse engineer what is needed, write tests for that, and then slowly work based on that. So know what the requirements are for the legacy code base and then build your knowledge on top of that.
What do you do if your expert really wants to code? Navigating and mentoring means no more coding for them.
So they can still code. So for us, our expert actually divided his time between mentoring and helping out and working on the new code base. So we gave him a breath of fresh air, and he didn't have to deal with the legacy monolith as much as he used to. So he still got a chance to code, but just in a different code base.
All right, last one. If a legacy data model in business logic in DB PKs, sorry, I think there might be some abbreviations in here, is solid but old legacy app UI and controllers have bugs, is rewrite doable? Would you like me to repeat that?
Can you repeat the question?
Yeah. If a legacy data model in business logic and DB PKs is solid but old legacy app UI and controllers have bugs, is a rewrite doable?
I don't quite understand that.
Not sure I do
acronym.
either, but if somebody's in the crowd who asked that, feel free.
I didn't ask it. I would say that means that what if the data model is perfect, but the application on top of it has problems?
Okay, so the clarification was, what if the data model is perfect, but the application on top has problems? I would say you can only confidently do a rewrite if you have a good suite of tests. Because even if the data model is perfect and you do a complete rewrite, you may inadvertently misunderstand the data model, or you might think something is important when it's not. You might think something is indexed and thus searchable, but it's not. So you really want to make sure you have a good suite of tests. And unfortunately, a lot of legacy code doesn't have good suite of tests.
All right. Thanks, Peggy. You guys give it up for her one more time.
Thank you.
And also for all of the speakers that we've had, this is the end. It's a wrap. You guys made it. Thank you so much for coming. Come back next year. And please go see Ship It Live in the main salon.